Welcome to our presentation today about the LLCAM. So yesterday he has talked about the core and also the utils of our modules. Now we'll be talking about the visions. So here's the brief overview of the vision. So as Nini said yesterday that we have some inner functions, so that are some pre-made functions, and we can also import our others API service from others website. So these are inner functions here. So first we have a YouTube Live, which allows you to capture the frame from the live stream. The second thing is the GPT-4v. Basically, when you are provided an image, the GPT models will give you a detailed description of that image. The third thing here is the YOLO, which is a computer vision model. It allows us in our LLMCAM to detect objects. The fourth one is the DG traffic cameras. So this one is linked to the DG traffic service and keep track of the cameras all over Finland. And the fifth one is the plotting. So as the name suggests, it will plot some data when provided. So first we will come to the YouTube live capture. For the brief overview, here's how the YouTube live work. First, we have a YouTube live stream. Then we can extract the current frame of the live stream using the YouTube download project. And from that frame here, we can provide it to the YouTube live class, which is a defined class in our module. It will store the information about that YouTube frame and other other data such as the file name. And another thing is that we have one instance of the YouTube lab which is called the Nakima Helsinki style. So this one is specifically about the Nakima Helsinki places. So first here, these are the Nakima Helsinki places that are listed here. And that is the cookies, like the optional data for the Nakima Helsinki style. So the main part here will start with here this stream URL. So if we have a YouTube live stream, we provide it here to the YouTube download project. Together with the optional parameters, we will be able to get the link that will give us the current frame of the live stream. So when we use it extract info from a YouTube live stream, this one will return us a JSON file, but here we'll have this link, which will be the current frame. So here's a example usage. If we pass to the stream URL here, the Nakima Helsinki URL live stream, then we will get this. This one will be the URL that store the current frame of the live stream. So next we want to show that frame. So here's a auxiliary function that allows us to show the frame. And for each of the frame capture, we will have a small part on the top, which will store the information about the places and the date time. So we have a small part here which will crop that part about the information. So this function here will convert the image to a string, and this later will be used in here, like the known places. I'm sorry, this will be in the known places. Okay, so this one will be the next main part of our YouTube live. This one is called the meta. So it will store the information about the date time and the places of the capture live frame. So when we capture a live frame here, as I told before, that they have a small parts in the corners. It has this kind of information. And then we will crop that frame and extract the information to store it into a function name here as You can see here, this will be the function name, and it will make use of the meta function to extract the information. So putting it all together, we have this example here. We first get the URL from the stream to get the current live frame, and then from that one we will show it. Then the frame will be cropped to get the necessary information for the function name and also for the metadata. And if the name if the live frame is not known before, so if it's not belong to the Nakima Helsinki, then it will not have the metadata. So that is why we will use here as a date time, like the current date time and nowhere for the default value to store the file. And then we will write it to our data folder. So for our data here, it will be LLMCAM because we have the environment data, or else it will just be the data folder. So here's the example output. This is where the process of extracting the live frame, and this is the part where I told before, like it has information in the top of the corner, and later then the data is captured to this file name. So because Kauppatori is also belong to one of the Nakima Helsinki places, so that is why it has the name and the date time here. And if we provide the URL of live stream that is not belong to any of Nakima, then it will be like nowhere. So to summarize, then the steps we've done here is first we provide the live stream URL, and from that live stream we will extract the current frame, and from that frame we will get the necessary informations and save the frame into a picture in the data folder. So how can this be modularized? We provide here the YouTube Live class, which will store the information about the frame. So most of the thing is explained detail before. So now we just pass it through here. So when we initiate the class, we have the basic information, for example, the URL of the live stream, and then the stream URL, which is the current live frame, and the direction which we will store the image to, and then the places, which can be nowhere or it can be something if this has been defined. For the file name, in the general case of YouTube Live, we only make it as a datetime current and then the places as a parameter or nowhere if default. And then the capture process goes as explained before. And not an instance of the YouTube Live frame would be the Nakima Helsingista Live instance. So this one will be more specifically about the Nakima, and it has some places as stated before, and the meta here would be able to extract those places. If in some case does not have the place known, then it would just be unclear. So the example of this YouTube live stream is here. If we provide us a Santa Claus Village YouTube URL and then get the place here as the Santa Claus Village, it will save us to this file name here with that timestamp and the Santa Claus Village as the places. And for the Nakima, so this part we did not provide any like specific place, and it cannot capture the place from the live stream, so it turns out to be unclear. So to put it all together for our LLMCAM model, here we have a function that will call the capture YouTube live frame, and it makes use of the YouTube live class and the Nakima Helsingista instance. It will text in a link, which is the YouTube live stream, and then a place that is the location of the YouTube live we're wanting to extract from. So how does this work with our LLMCAM? Um, so first here you can see we will transform this to become the tool schema that is compatible with the GPT chat completion. And then we will just ask the GPT to extract the YouTube live. If there's no link provided, then GPT will use the default one, which will be the Nakima Hasingista. And if there's a link provided, then it would be that link. So here, when you specify that we just want to use a default link, it will just use the Nakima Hasingista, and the data will be captured and stored to this file name. So this one here is able to detect that the places will be Presidentina Lina instead the unclear as before. So in short, this YouTube live module, it will be able to extract the live frames from a current live stream and store it to a data folder. And together, it will have some necessary information about that image. Next, we will go to the second model, will be the AskGPT-4v. The main function of this model is to pass a image to GPT and ask it about the quantitative data, a very detailed description of the image. The general process goes as this. So we first have an image. We will need to encode that into a base64 string because that will be the requirement when we pass the image to the GPT model. And from that, we will pass also the prompt, and then GPT will give us the image description. So here we have, for example, a file, an image file, and we first will need to encode it into a base64 string. So this the previous file here, and just some first few characters from the base64 string. So as the chart before showed that we also need the prompt for the GPT. So the prompt for the current prompt would be describe this image quantity as many as possible in the JSON format, and all the values should be numbers. So what does that mean? This means that we want GPT to output the image informations like this. It should include, for example, the timestamp, the location, the objects detected in the image in this format. So how does that work? In then that work. So we will need to use the chat completion from the Open API here, and it will be inside the message. So the content of the message will be our image and also our prompt. The image would be encoded in the base64 string, and it will be passed here to the GPT, and then the prompt will be passed as a text here, so that GPT knows which kind of outputs we are expecting. So when we pass that to the ChatGPT GPT photo, then it will generate a response looking like this. So this is exactly the same as the prompt that we provided before. Like we have the timestamp, the location, the car, the truck, the detected objects. Inside that, the visibility, the water bodies. So these are the very detailed quantitative data information about the image. And the next thing here, we will load that response into a JSON format and return that to have a kind of pretty print JSON file. So instead of a one line here, we have here the very nicely print JSON file. So to put this all into one function that will be callable by our model LLMCAM, Then we will first have the path of the image as a string. Then the path will be encoded into a base64 string, and then we again create a prompt here as a question, and then pass it through the GPT model to complete the text request. So in the end, it will return the response as in the JSON format, like this. So this is an example of how the response would be when we pass to it the image where we had in the beginning. And to put it into our GPT workflow, first we will transform it into a tool schema, like that will be compatible with the GPT. And we have here two modules. First one will be the capture YouTube live frame that I have discussed before, which will capture the live image from a live stream. And then the second would be the ask GPT about image file, which is basically this model where we'll ask GPT about the quantitative data for an image. And then I will ask GPT to use to capture a live image using the default link, which is the Nakima Alcingista. Then it will have the image here captured into this bar. The next question I would ask it is to extract the information about this image. And how does it know? It knows because the description of the activity 4V, it has that extract the detailed description of the image provided. So it knows that when I ask it to extract information, then it will call the ask GPT-4V about the image file. Then it will return to me a very detailed description about the image file. So this is exactly the same as the prompt that we had before. So to summarize, then the GPT-4 Ask GPT-4 module here, it will allow us to extract the detailed information about an image given the output format. If we want to modify the format and somehow include more information, then we can modify this prompt here, and GPT will adapt to that to generate a detailed response. Coming to the next one would be the YOLO module. So for this model, here, the YOLO here is a computer vision model. It allows us to do a lot of tasks, for to detect object uh, segmentation, and also trackings. For our LLMCAM model, we only use the object detections as the main part. So first we have an image capture from Santa Claus. That will be an example image here, and we'll see how YOLO can detect objects inside that image. So we have here a pre-trained model from YOLO. It is the syntax will be just pass the name of the pre-trained model, and then that will be the parameter for the YOLO here. For our model, we only use the YOLO version 8 small because it allows to have very fast prediction, but as a compensation, it will not have the highest accuracy. We also the YOLO also have other models such as like the YOLO V8 medium or the large one that will be more precise, but it will be a trade-off between the speed and accuracy. So to generate fast response, then we use the YOLO V8 small here. So first we define the model, and then we pass the image here together with the confidence threshold. So if the threshold is high, then the model is very certain that an object is a person or a car. But if it is low, then even though the object is not that certain, the model will still produce that output. So when we pass the image and the confidence threshold to the model, it will give us a result. And then we can show that result here. as seen. So as you
Uh,
can see,
can,
yes,
can I ask one question?
yeah,
I think you are taking the output of the first output from the model function. Uh, what what is it returning the for the other thing?
do
Does
you mean like what
yeah
this
yeah
results?
yeah
I think this
yeah
one is a defined class of the YOLO, so it's not like a flat image or something. It will be like a class that has some informations. So I think here if we go to the next part here, as you can see, the result has more parameters inside, and we can use that to extract more informations.
okay. No, I think my question was model function you taking the first element uh,
Here.
specified by the zero at the last.
Yeah, yeah, yeah. Okay, so because like this results here is like it has a lot of things. So uh, oh, what can I say? I think that is not like a flat object. I think it will be like I don't remember exactly what it is, but it has a lot of things. So for example, this it will have like the result here would be like a class, and then under that it will also have the like the classes. So what are the objects that can be detected with this model, and also all the information that are related to the model itself. So if we want to have the result here, then we will just need to, I mean the image here, then we will just need to take the first one.
Okay. Uh, is it possible to run the this notebook till this point and to see what it returns?
Yeah, okay, I can try running it. Uh, I think it would not be this exact same thing because this one is from the GitHub, so it's not in my folder. I can take another image. Uh, I don't think I have this one. I can try. Yeah, okay. I don't have this one, so I can probably try taking another one. Is this a fan of them?
It's the brackets or no? I think you should also probably use the Santa Claus village image because the ones captured with the other cameras doesn't usually have.
Okay, this one is detection. Okay, I can try with this one. Oh,
Also, where are you starting the Jupyter notebook?
yeah, I think it's like because this one I don't have
Mm-hmm.
the like the parent data folder. It's like the same as this folder, so maybe that's why. Let's see if I can run it. No, no data cap. I'm starting here, so I suppose it should be. Yeah,
Uh,
it's
then just data in the beginning, not with the yeah.
okay.
Right. Oh
No,
no.
okay. Uh, yeah,
Did
okay.
you
Yeah, maybe
get
I
uh,
just get the.
just the environment or like the data environment?
You can insert the column above uh, and check the current directory.
Oh, I think you can use absolute path.
Yeah, I think it would be faster to use the absolute path. Okay, let's see. It looks. Oh, oops. Okay. Yeah. So like the YOLO V8 small is very fast to download because it's small. Mm. Oh, is it that again? Okay.
Yes.
And then I will just put it here.
You need to
Oh,
use the
oh,
same.
okay. Here. Yeah. So yeah, we can try to see what does this produce. So here is like the defined for the model. So for example, here these boxes will be used if we want to extract the mask here, like this one. These are the boxes, and it has like these names here, like what objects can the YOLO V8 detect. So it cannot detect everything. It can mostly detect like countable objects. And for example, the road or the sky, it will not be able to do the object detection. Yeah. So some kind of like related information to the module.
Okay. How many outputs did it return?
You mean the size?
Yeah. Numbers. Yep. Yeah. That's I want to know.
Uh, it's just one. Wait, should it be one? I think it should not. That's weird. Oh, yeah, yeah. It's actually only one. So even though it's like inside a list, it only
Okay.
has like this classes here.
Okay. 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 Okay.
That will be like the results of the YOLO module. So it's like the result object.
What's the inside? Are they dictionary or?
Um, mm, you mean like here, like this one?
Yeah. Yeah. Yeah.
It looks like a dictionary to me because like I can. I mean, I think it looks more like an object to me because it can be used like this. So like
Okay.
if you have a result here, you can call the object the
Okay.
boxes.
Can you try to uh, 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 the cell on 12? You just specify the blanket zero, and dot keys.
Key points or like key.
Keys,
Oh, yeah.
keys,
Okay.
and it has a function.
Uh,
Keys. Huh?
oh, okay. Keys.
But-
Yeah.
Yeah, yeah.
Uh, yeah. I think it's not a dictionary.
Dictionary.
I think it's an object, so that may
Okay,
be why. So like here's a detailed description of this object.
okay,
Mm, yeah. So as I was speaking about the confidence threshold, so for if we put it as like very low here, like 0.25, then even though this part it does not look like a truck and the model is not that confident, but it still returns the output because it's above the threshold of 0.25. And continuing to this part, how can we extract the information from the detection? Then, as we have here before, this model here is testing a an attribute called the boxes, and the boxes will give us this kind of like result, and this results mean that like the dimension of the box, and it also I think it should have the information about like which object is detected at each box. So this is how it can be used. And here, yeah. Oh, yeah. So it has this classes here. So this class here, I think 0 means person, and then the 7 means the truck. So if we can compare with the image, we have 5 person. So correspond to 50, and then we have 17, which will be the truck. This number will be indicated by the classes before. So we go back here. Here we can have see that 0 means person and the 7 means trucks. So that is how we can uh, like count the number of objects detected in an image and store that to a JSON file. And putting them all together, we have first here a method called detect objects, which will take in an image path, and a conditional parameters will be the threshold, confidence threshold. So here it will be default as 0.25. And the process goes the same as before. We have a model, and then we pass the image to that model, and then we save that model detection image to a file. And then from the results, we will extract the number of objects count detected inside the image and return that count dictionary. So yeah, so how to use it? Yeah, we have it here. If we pass it with the file, the image file that we had before, it will return us with a dictionary that will have the objects and then the number of objects in that image. Then we will process the same way as the two other modules. First, we will need to we will need to transform the functions into a tool schema that will be comparable with the GPT. And then in this demo, we also make use of the SGPT4 and also the capture YouTube Live. So first here, we'll ask it to capture a live at Santa Claus Village, and it will be saved into an image. And then we will ask it to detect the number of people in this image. So here, this will be the prompt for using the detect objects. And then the GPT will know that it should use the detect objects, and reading the results from that function, it will return just a number of people that are detected in the image. So for example, this one here, we have 19. So in summary, then the YOLO model here allows us to detect the objects inside an image, and it can be integrated in the LLMCAM together with other modules such as the YouTube Live Frame and RCBT. The next part will be the DG traffic cam. So this part is more like a link service to the DG traffic. And the DG traffic has some cameras over Finland and like the cities in Finland, and we will make use that to capture the image from that city. So first here we have the stations. So DG traffic also have a station, a link that lists all the stations that I have it here already. So this will be an example of this station. This will be one station here. It has the ID of like something, and then the name of the city, like Porvo. And it also has this ID here will allow us to access to the more detailed version of that station. So if we go to the station and pass that ID to the URL, then we can get a detailed description of that station. So for example, here we have like the properties of the IDs in the name and the names of the road in Finland or like in Sweden or like in English, and also the road address and like the city, the province, the municipality. So the presets here will be kind of like a summaries of the camera. So it has the ID and the name of that camera, the name of the station. So now it's in Bravo. And if we go to this image URL here, we can actually access the current image at Portable. So if I reload it again, okay, so nothing that different. So maybe it's not captured live, but yeah. So basically, this will be the image that is correspond to the station of this ID. And how can we make use of that? So first, we will need to create an address book that will be the informations of the all the stations in this URL, the station URL here. So we first get all the station by send a request to the URL station, and then for each station we will extract the necessary information. For example, the station ID, and then again we send the request to that specific station. So it will be like this one, a specific station like this. It will has more detailed information about that station, and then from that station, we will collect the data in the presets. That will be mostly about the municipality, the province, and of course like the name of the station. Here, so this will be the address of that camera, and also the image URL that would be this one, like the image that is captured at that station. So this altogether will be built as one address book. And then we have a function that will be called address book. So this one, we can either use some existing book that we have defined before, or we can forcefully update by calling the new one. So if it's not force update or like there is no preset image URL like address book exists already, then we will return a new one from this station's URL here. Yeah. And this camera address book will basically text in the data from the address book and then dump it into a JSON file. So that JSON file will looks like this. It will be a list of many stations, and each station will have the address and also the image URL that is tied to this station. So it will have here like the name, the roads, the municipality, the province, uh, here. Yeah. So that would be the address book for all the stations across Finland. So now, how can we extract the image at each station? So as we discussed before, here each station will have a name corresponding. So to here, this one will have the name as a portable. And what we want is that we want to use the keywords just as like portable, and then to get the corresponding stations. So first we still send a request to all the station, and then we find if any stations has the keywords inside its name. So if the keywords is inside the name of that station, then we will add it to our output. So from the if this station here has a portable inside the name here, then we will add this station information into the output. And from the next one, it doesn't have portable, so we just skip it. like that. We collect all the camera stations that has the keywords name inside. Here's an example use. So if we just say stations Bravo, it will return us a list of stations that is set up at Portable. The next thing is that we need to extract the presets information, which will be this one. This is like the summary of that station. It has the ID and also the name, and also it has this image URL that will be necessary if you want to extract the image at the camera station. So again, we send a request, but now we do not send it to the all station. We just send it to one station that we want, and then we get the presets dictionary here. And in this preset dictionary will have an image URL that will lead us to the image at that weather camera. And again, so now we'll be able to access that image. We will need to download it or like capture it and save it to our like local data folder. So we will send a request to that one, and then so we will send the request to that image URL, and then we will download it with the date, time, and place. So here is the return output would be the headers and also the path to the image that we have just save it to. So here from the if we use it like this, the first one with headers will be something like this, and then the second one will be the path. And if we display the path, then it can show it the image captured the camera that we stated before. So again, now we're putting it all together. We first, it will be a cap function that receive a keyword that will be the place that we want to extract the camera from. And the default value would be portable. So if we do not provide anything, it will just extract information from the portable. So first here, we will pass this portable to all the station, and it will return to us a list of the cameras that available at portable. I mean the keyword, and then we take the first one, and then again we pass that information to the presets, which will now lead us to the image URL, and we capture the URL into our local file path. So if we now just pass to the cap then keyword portable, it will so it looks like this. So this is like, but it was just like some days before. So this is the same one. So it's at portable. And to put that into our GPT workflow, when we will again have to make sure that it will be understandable by the GPT. So we need to transform it into a schema. And now we also test the function of the camera address book. So if we first ask GPT to name some location inside the where the camera address book, we were able to list us some here from the like portal, like info and so on. So these are the stations that have available cameras, and now we will ask it to capture a camera from Helsinki, and also ask it to tell us some basic information about it, which will be utilizing the AskGPT about image file. So first here it will be able to capture the image from the weather station at Helsinki using the weather address book, and then that image file will be passed to the AskGPT about the image, and the response will be like this. So this one is exactly the same output as we discussed before in the GPT-4V module. And if we further ask it to capture the image, the objects inside this image, then it will provide us some response looking like this. So it will be able to detect 7 cars using the YOLO model. So as I said before, like YOLO will not be able to detect kind of like everything. So from the trees here or like the light here, it will not be able to detect, but it will detect more kind of like instance or like the countable objects that has already been defined in its model. So to summarize, this DTCAM model allows us to extract the image from DigiTraffic weather camera at the cities across Finland. And if we use it with other module from the LLMCAM, we can extract further information, such as like the objects inside the image, or the basic information like how the light, how is the situation, the date and the time, the location also of the image. The final part of this vision model would be the plotting model. So the plotting, as the name suggests, it will be able to plot some numerical values received from the YOLO or the GPT. So the main purpose of this model is to plot the maybe to plot the object detected from the YOLO or like object detected from the GPT, or maybe it could also plot both of them to compare how GPT and YOLO perform differently even though it's the same image. So we first here have an example image, or maybe two example image, because this one will be able to plot the number of objects in a list of image, and we can see how how the trend is going inside the like a time range or something. So if we say state here the object to be detected is the person, and we asked the GPT, then first we will still ask GPT about the image in general, and then we will count up count the number of person inside the response. So here we will from the info here we will get the number of person or the number of object. If we don't have any, then we will just put it as 0. And then we plot it. So for the two images above, this is the plot that returned by the GPT. So next we will test it with YOLO to see how differently those perform. So the YOLO modules we discussed previously also provide us the output of a JSON, which will have the objects and the number of objects. So we can still use the same format here that we get object from the output. And if there doesn't exist such object, then we will just put it as 0. And for the two images both here, you can see that YOLO have some kind of like similar detection for them, and it will be roughly around 20 compared to the GPT model. It will be much smaller. And then if we ask it to, yeah, and then if we put everything into one, so we will first we'll have a function called the plot object, and it will first receive the images as a list of image, and then the object, which is the object to be detected. Currently, the method only accept one object to be detected per a call, and also the methods that will be used. So, for example, like GPT or YOLO, or it can only be GPT or only YOLO. So, or we will have the default value as like GPT and YOLO, but it can also be changed when calling from the LLMCAM. So the same thing as before, we will first uh, detect which method to use, so YOLO or GPT, and then we go to each of the method. So if there's YOLO, then we add the counted objects by YOLO, and if GPT, then we add it by the GPT. And if there is both YOLO and GPT, then we'll plot the figure of two subgraphs. So that's why we need to put it like here separately. So this one will be the YOLO plot and this one will be the GPT plot. And if there's only just one or two, then we can just use the same syntax as before. That is like just take one of the count and then plot them together. Plot them separately. So the results will be like this. So if we have a plot object and we pass in the path, which would be our two images from the start, and we ask it to detect person using both GPT and YOLO, then the plot would looking like this. So again, you can see that like the YOLO will be kind of very consistent between uh its detection because it's like David model, but the GPT on the other hand will be kind of fluctuating because it does not have a solid definition for how the objects should be detected, and it just have a general overview of the image, so it fluctuates. And looking at this also, we can see that YOLO would be better when we have kind of like a sparse frame with some very distinct objects. Because if we have a crowd, there are too many people, then it will not be able to detect fully compared to GPT. GPT has a larger, like a kind of more general overview of the image, so it can provide us a rough number of how many people there are, but it cannot go into detail of like what part of the image are person and what part are not person or something like that. And to simulate that in the GPT framework, we first here also need to transform the plot object into a tool schema, and we also need to provide an auxiliary function here as a list image file, which allows GPT to access our local folder for the image data. And then we will first ask here the GPT to list all the images from the Santa Claus village. So it will traverse through our folder and then to extract all the images that looks somewhat related to the Santa Claus village. So for, for in this example, we found three images from the Santa Claus village, and then we will ask the GPT to plot the number of people in these images using both YOLO and GPT. And we also ask it to show the path to the plot. Uh, so here are the response. So when we ask the GPT to, we will ask the LLMCAM to uh, do the object detection in these images, it will do that using both YOLO and GPT, and then it will save it into a path here. So if we display the image plot in this path, it will give us something like this. So this one is because we ask it to use both the YOLO and GPT model, so it will be a figure with two subgraphs. But if we ask it to just use the YOLO or the GPT, then we will just only have one whole figure will be one graph. So to summarize this part, the plotting will be able to plot the objects detected in the images using either YOLO or GPT or even both, and return us a graph that will show us the plot. And we also have some small demo scenarios that can kind of show how the LLMCAM work in general. So first we import the necessary functions here, and I had the composition beforehand, so now I just need to show you. So for the system images message, it will be that like it will tell the LLMCAM to be, or like the GPT LLMCAM to be a helpful system administrator, and it should help us, the users, to answer the questions. So in this demo, it knows that what it can do. So for example, it can add a new service. Okay, so this one does not. show the whole thing. Uh, okay, so but in short, like so this demo would be demonstrating the capability to integrate a new API service into the LLMCAM and to make use of that API service. So before this point, we don't have any road traffic API, and we cannot access the information at the traffic jam or the Kubio or something. But now that we have after we have integrated the API service into LLMCAM, we can ask it where the traffic jam exists right now, and it will return us a list of stations that are having some minor or like major accidents. And one of them was the Kuopio, so I asked it to show the Kuopio image. And here, oh yeah, okay, so this one here is the response from the GPT. So when I ask it where the traffic jam exists right now, and it will show me the stations from the DC traffic. So the station from DC traffic, we are having some kind of issues at the moment. From the here the Salo, here the ferry traffic is suspended, and for the Kemi here it will also have like the ferry traffic. So this one is not like the inner the pre-built functions, but this one we will outsource to the DC traffic, and we will rely on their services to extract the information. The next demo scenario would be kind of similar to what we have done in the YouTube live. So this one will be capturing a live frame from a YouTube live stream, and then we will ask it to detect the objects inside the image. So first here we will ask it to capture the live frame in a capture, and then we will ask it how many people are there, and then it will use a YOLO to detect the number of persons inside that. So should be 9. And then the image path is shown, and then we ask it. Then I ask it to list the image captured the Santa Claus during yesterday and today. So it has some number of image, and then I ask it to plot the YOLO by using YOLO and GPT. So that is kind of like an example of how the LLMCAM can be used, and yeah, and I think for the better experience, then using it from the application or the hands-on demo would be more practical, and that will be presented by Yi on the next part of this series. So this is the end of my presentation, and thank you for attending.
Thank you for a nice presentation. And does any of you have any questions? I'm going to stop recording now.